Hello dear student, I am Monroe Islam. Today in this video we are going to discuss an important question of TI in NBHM 2022. Okay, so this is a question from compliance analysis and this question from Bilinear transformation. Okay, so let's start. What is the question? H equal to a plus ib where b greater 0 means the upper half plane given upper half plane a plus ib b greater 0. This is upper half. Okay, upper half, you don't here h is denoted by h. So upper plane, open upper plane means axis is not included. Okay, open upper plane and phi being another function on h defined by phi s subset h means it means phi map upper half to plane to upper half plane. Phi maps such upper plane to upper plane. Phi map upper half plane to upper plane. Subset xy plane, it is UV plane, then it may have upper plane to upper planes. It means v greater 0. So phi is a transformation that may have upper plane to upper plane. With such a condition, phi I equal to I and phi 2I equal to I by 2. These two conditions are given. Okay. Then what is the value of mod of phi of 1 plus I? Okay, we have to calculate this. So we know every Bilinear transformation from that maps upper plane to upper plane be of the form. Okay. So you know every Bilinear transformation that maps upper plane h to upper plane h be of the form every Bilinear transformation that maps upper plane to upper plane be of the form fz equal to az plus b upon cz plus d. Okay, this is the form az plus b plus az plus b upon cz plus d, where ad minus bc should get at 0. Okay, this is the restriction for which for this condition only the upper plane map upper plane. Okay, the transformation f map upper plane to upper plane. You can say it phi, it is phi. So therefore phi z equal to az plus b upon cz plus d. Okay, where ad minus bc, this should be greater 0. Okay, I have named it 1. Now here two conditions are given. I have used phi subset h. This means upper plane map upper plane. So I have used the Bilinear transformation that map upper plane. Okay, now use the two conditions, phi I equal to I and phi 2I equal to I. This what this gives. So first use phi I equal to I. If I use phi I equal to I, this condition, first condition, so this implies phi I equal to I, ai plus b. Okay, this ci plus d. So this multiply this gives ci into a minus c plus di equal to this ai plus b. Okay, equating the real part to real part. Here real part is minus c, real part is b. So b should be equal to minus c. Here imaginary part is d, imaginary part a. So d should be equal to a. So name it 1, name it 2. Okay. Now use the second condition. If you use the second condition, phi 2I equal to I by 2. Now phi is also given. Phi of 2I. This maps I by 2. Okay. Use this. If you use this, you get I by 2 equal to a into 2I plus b. Okay. Plus cz c into 2I plus d. Okay. So this gives I by 2 means 2c, multiply this, so this gives 2c and this gives di, this gives 4a I and this gives 2b. Okay, so equating the real imaginary part we get. If you equate the real and imaginary part from both sides, it gives b equal to minus 2c, okay, and d equal to 4a. So 2b equal to this is 2b equal to minus 2c and b equal to 4a. So from here, if this gives b equal to minus c and this gives d equal to 4a. Okay, 3. I name it 3. So now we are left with 1, 2, 3. Use 2 and 3. Here it d equal to a. Here we have d equal to 4a. d for a. So use this d equal to, therefore d equal to a, and here d equal to 4a. So from here you can say a should be equal to 4a, means 3a equal to 0. So there a equal to 0. Since a equal to d, so d equal to 0. So this gives a d both 0. Okay. Now a d are both 0. Therefore the transposition phi z equal to az plus b upon cz plus d. Here a and d both 0. So a put a and d 0. So this gives b upon cz. So this is transposition b upon cz. Now one more condition is here, b equal to minus c. Here b equal to minus c, into we also get b equal to minus c. So if you use this b equal to minus c, if you use this b equal to minus c, so this gives minus c c z. Okay. Here one more condition also we have ad minus bc get at 0. Okay. We have ad minus bc. This condition should be get at 0. For this only upper plane map upper plane. Okay. We have also ad minus bc get at 0. This condition only ensure that upper plane map upper plane. So you have to use this condition. So if you use this condition, ad minus bc get at 0. Okay. Now here ad a is 0, d is 0, both are 0. So this gives 0 minus bc get at 0. Okay. Now this gives minus bc get at 0. So we have phi z equal to minus c upon cz, where minus bc get at 0. Now you have b equal to minus c. Since b equal to minus c, if you put b equal to minus c, so this gives c square get at 0. Okay. Now c square get at 0, it ensure that c is never 0. Okay. C square get at 0 ensure that c is never 0, because if c is 0, then it implies c square is 0, but it says c square get at 0. So c, from here you can say c never 0. Okay. C never 0. So c never 0, you can cut this c. So this gives phi z equal to 1 upon z. So the transposition become phi z equal to 1 upon z. So this is the transposition, phi z equal to 1 upon z. Now we can find out the value of phi at any point z belongs to upper plane. Okay. So we have to find the value of phi equal to 1 plus I. I think phi equal to phi at 1 plus I with mod. Okay. So find this phi. Now from this you can say phi value of phi of 1 plus I, this will be nothing but 1 upon mod 1 plus I. If you take mod both sides, so this gives mod. So this gives mod minus this gives mod 1 plus I. Okay. This mod 1 plus I. Mod 1 plus I will be root under 1 square plus 1 square. 1 square plus 1 square. So this is 1 upon root 2. Okay. So phi, so therefore phi, you can say phi 1 plus I, this mod value is 1 upon root 2, and this is the answer. For this question, 1 upon root 2 is the answer. Okay. Hope you understand my solution, and it's a very nice question. In upcoming video we will discuss more question. Okay. So its answer will be 1 upon root 2. Hope you see this answer is written. Okay. So please subscribe my channel, and we'll give more solution in upcoming videos. Okay. So thanks for watching, and thank you.